Assalamualaikum and salam sejahtera to our lecturer, Dr. Rizwan. Okay, today we get the assignment dynamic, question 1 and question 2. So, I want to solve the equation of equation number 1. Okay, so the equation, this is the first equation. So, if we must draw the FBD diagram. So the FBD of the ball, we get the weight, and then we get the Newton, and then we get the force. And then the equation must to draw kinematic diagram. So in the kinematic diagram, we only get the mass acceleration. Okay, next we go through to the B question. So the B question need to know velocity at point B. So as we know, the velocity using a formula at the given. So the equation the given is summation T A plus summation U A to B equal to summation T B. So the formula the given is principle of work and energy. And then we know the summation T is the kinetic energy, and then summation U is work done of the ball, and then this summation T kinetic energy final. So summation kinetic energy formula is 1/2 mv square plus mgh equal to 1/2 mvb square. Okay, we go through the equation. So we know at the point A, this is point A. So at the point A, the equation not given the mass and velocity. So we can go through the zero. And then we go to the mgh. Mass not given, and gravity is 9.61, and height we have two height. At the ball to the ground we have 3.5, and then at point B we have y0 is 1. So we just put 3, 1 minus 3.5 equal 1/2 mvb square. Okay, the polarity at the work negative, because negative, the work go to through the down, time the down. So the probability is negative. So there's at this equation, we can cut the mass. So the answer we calculate, we can get VB equal to 7 milli per second. Okay, next we go through the next question, question C. Question C, we need to solve the distance at point B. So the distance at point B. So formula are given. Formula are given for the horizontal x component. We know x equals to x naught plus Vx naught t. So x naught x naught we get at the graph, the assignment 1. So we get the x naught is 0. So we put the data at this equation. So plus Vx. Vx we know. Vx also known as Vb. So Vb, as we know, Vb get 7 milli per second. So we put the 7 and then t. T is the unknown. So the answer is 7t. So for the vertical y component, also the given. So the equation, the formula is y naught plus Vy naught t plus 1 over 2 a y t square. So why not? We get also at the data, so we get the 0 and then plus Vy not t, not given, so 0 and then 1 over 2 acceleration are fixed, so negative 9.81 and t squared. Why we go through the equation. Y is the vertical at point B. So also we know vertical point B to the ground is 1. So at y we know 1 negative. Why negative? Because the ball go through the point B and go at the ground. So negative 1. So in this question we get 0. So 1 over 2 times negative 8 minus, we get negative 4.6905 t squared. -1. So we get the answer of t is 0.45 second. So we get the t answer. So we go sub equation 2 to the equation 1. So x 7 times t. T we know the answer is 0.45. So we just throw, and then we get the answer 3.15 meter. Okay, the last question B. Question is velocity at velocity when ball hit the ground. So as we know, when we to solve the velocity, we using the same equation at the question B. So equation are same. Using a kinetic energy plus work done A to ground. We name the C equals to kinetic energy for B. For C. And then we go to the 1/2 mVA square plus negative W equals to 1/2 mV square. So as we know, at the point A, no data are given, so we can cut the zero. So negative plus and negative, we get a negative W mgh, so equals to 1/2 mv square. So we can cut the m because are not given, and then gravity is 9.81 times height. Height also get a 2 height. The height first at ball to the ground, we get 3.5, and then height 2 at the ground. At the ground C, at point C are 0. So 3.5 minus 0, so we calculate, we get the answer of V, C. The answer is 8.29 milli per second. Okay, thank you.
Assalamualaikum and salam sejahtera. Okay, today I will discuss about our assignment, question 2. Okay, first, this is the FBD for the question. Okay, the object is slip from A that we know as a beginning slip to the B, and then it passed through to the point C and rebound to the point B. Okay. Let's go to the question A. Velocity of the object after a rebound from the ground. Okay. We know that the coefficient of the restitution is 0.7, and we know the velocity at point B when we use the formula of work energy. So this is the velocity at point B. Okay. So from the vertical motion, we use the formula to find the velocity at y-axis. Okay, this formula we use to find out the velocity at point C at y-axis. So we doesn't have the velocity at point 1 at y-axis. So we consider that it will be 0 and plus 2, and AC is 9.181 negative, and we know that the SC1 is 0 and S1 is 1. So just after we calculate the equation, we get the answer. Velocity at point C at y-axis is negative 4.43 meter per second. Okay. So we have the coefficient of restitution. The formula is equal to okay. This formula, we want to calculate the velocity at point C at y-axis. So we got the coefficient of restitution 0.7, and velocity at y-axis is 0 and minus 2. This is what we want. This is y. And this is what we get, this one. It's minus 0. And after we calculate, we get the velocity at point C at y-axis is equal to 3.101 meter per second. Okay. Since the question is the velocity of the object after it rebounds from the ground, so we use the y square is equal to so we use the Pythagoras theorem. And after we calculate, we get the answer is 7.66 meter per second. Okay, this is the final answer for the object after it rebound from the ground. Okay, we go to the question B. It one, we find the maximum height for the object after it rebound. So the question want the height of the object after it rebound from C to D. So we use the kinematic equation to get the height of the object. So this is the equation. This is the equation. This is we know that the value is 0, and we get the value 3.101 from the question A, and 2 AC is negative 9.81, and this 0, and this is 1 from the height of this. So we calculate. This is 0, 2. So after we put the value to the equation, just change the h to here, and we calculate the equation as usual. So after we calculate the equation, we get that the height of the ball, the object of the ribbon, is 0.49 meter. Okay, that's all for question 4B. Thank you.